Hello, welcome back to LeetCode Daily Live, where I do the LeetCode Daily question raw and uncut. So let's get started. So today we have another medium. Uh, yeah. So the question is find unique binary string. Uh, might be exponential algorithm again because of the small bounds. Yeah, and so we are given like a list of string, which can either be 0 or 1. So hence the binary string array. Yeah, okay. All the strings of nums are unique. Right. Um. Right. Yeah. Let's go up and see what it actually wants then. Yeah. So given an array of strings nums. Uh. Yeah. Actually, I do like to look at the constraint first because that gives you kind of an idea on like what kind of algorithm you have to use. So like that's why I did that. So given an array of strings nums, containing n unique binary strings. Right, so each binary string is of length n. Return a binary string of length n that does not appear in nums. If there are multiple answers, yeah, you can return any. Right, so let's see. So we just have to return any binary string that, well, that is not seen, and anywhere. So, do we even need an exponential algorithm for this? I feel like if we just sort like all the strings, like because we only have how many strings do we have? Does it say how many strings? Yeah, I'm a bit confused because you can definitely just sort the string, and then if you only have 16, you only have 16 strings maximum. That's very strange. Okay, anyways, so 101 does not appear in nums. 000, 010, 100. Yeah, okay. So, that is very strange. Return a binary string of length n. Yeah, we can just return any string. And does it say what to do if you can't return any? So let's say like if n is equal to 2, but you have like 0001, 10, and 11. Well, none of the length 2 strings are unique, like are not in nums already. So yeah, this question is a bit fake, I guess. But do we just assume that n is 16? Because that would be pretty trivial, I think, actually. So like what you can do is you can just generate, like you can just make like a way to generate all the different binary strings from, well, from length, like for length n. So let me draw an example, right? So like let's say for 0 and 01, well, you can have a generator that generates like all the links to binary strings. So 0001, 1011. You can do that, right? And basically you can just check the membership here. So 00 is indeed like in nums, so we can't use that. And then we just go to the next one, and then we go to the next one. What is the time complexity for this? Well, assuming that the check here is going to be O1, well, like we can just use a set or something. So if that's O1, and we only have n elements on nums, well, at most we have to check n plus 1, like different combinations, right? So yeah, and if n is 16, well, it it will be trivial in this case. So yeah, I'm not quite sure what is going on here, but let's just code it up based on what they have given, and maybe we'll run into some like wrong answer in some hidden test, and we can see what they actually want. So yeah, let's start coding, I guess. So we have n equals length of Hmm. Yeah, I'm really confused because like the length of nums is n, but the length of nums I is also n. Yeah, but then it says like nums I, which is supposed to be a string, is either 0 or 1. So, yeah, this question is not that well written, I think. But yeah, let's just go with what we have. So, we have length nums. Maybe we do nums 0. It will be a bit nicer because we don't really care about how many items we have in nums. What we care about is how many, like, is the length of the actual strings, like in nums. So we have that, and then we probably want a set. So we'll call it like scene. Um, yeah. So one way to optimize this is instead of generating every string, we generate the corresponding number. So what I mean is so instead of doing like 0001 1011, we can basically map this to, well, 0123. Like we can map it like, so this is the binary representation and that's the decimal, right? So if you map it back to decimal, it will just be a lot nicer to deal with. And well, for the binary strings in nums, we can also map them into decimal. So like we'll put that in a set, and like when we see the first decimal that's not in scene, we can convert this into the binary string and return it. Yeah, so yeah, let's just do that. So for x in nums, maybe we'll call it binary string in nums. Oops. So how do we want to go with this? Well, it doesn't matter which way we are looking, so why don't we just do for I in range, and we have a counter, so yeah, count, yeah, let's just call it count, whatever. And then we can do multiply here, so we'll start with 1, of course. So if binary string I is equal to 0, then we don't have to do anything if it's 0, because yeah. But if it is equal to 1, we want to let's maybe call this like the map num multiplier. So for the map num, well, we can just do we can just add the multiplier, right? So what I mean is, let's say we have 101. Well, we can just check for this one. So the multiplier would be 1 here. And if it is a set bit, well, we can just do that, right? So if we set the multiplier to like 124, we can convert that to decimal, right? So yeah, that's easy enough. And then, of course, we have to double the multiply for the next step bit, like for the next bit. And after that, we'll get the mapped num. So like that'll be the decimal representation of the binary, like of the binary number we have for a binary string. And now for I in range, well, how many numbers do we have to check? Well, we have to check from 0 all the way to like 2 to the power of n, right? Because that's the number of binary strings we have to deal with, like that is of length n, of course. So we can just do scene, wait, not scene, 2 to the power of n. So if I not in scene, well, we just want to generate the string. Well, actually, we can return like, I don't know, an NP string outside. Like, we probably wouldn't reach this, but well, the spec is very vague, so I'll just do this in case. So if I is not in scene, well, we want to generate that. We want to generate the result string. So what do we do here? So we want res as a list, and then like afterwards we can combine it. So for for j in range n, if, well, we want to turn this number into binary, so we can just do if I mod 2, so that would tell us the set bit, right? So if that's true, actually, maybe we do have to worry about the order. Let me think about, like, do we have to worry about the order? So let's say if we have like 4, so we want to map it to 100. So the first one, it will be well, actually, we can just reverse it as well at the end. Yeah. So like for my algo, because like if the number mod 2 is not equal, like it is 0, then it will be 0, and then like, so it will be 0, 0, 1. But how are we setting these ones actually? So like for 0, 0, yeah, because we are reversed, like this is reversed, we also have to reverse this, right? So like 0, 0, it will give like, well, it will give 0, 0, 1, because like the multiply for this is 1, multiply for this is 2. So yeah, maybe it will be slightly nicer actually if we do this reversed. It's just a bit nicer to understand the code, I think. And well, we can just multiply that. So now we are doing like from the end. So like now we are going from the end. And so when we convert this back into a binary string, it will be, well, I guess a bit nicer as well. Like it's easier to logic with, definitely. So rest list, append. We want to append a 0. Oh, we actually want to append a 1 here because I mod 2. Like otherwise, we do want to append a 0 here. And after we have formed the string, we can just return. Well, we have to reverse it, of course, but we can just do join reversed rest list. And I think that should solve the problem. Okay, apparently, you know what? What did I do wrong? Let's see. So yeah, why is it outputting 0, 0 here? Well, let's print scene, of course. It's the easiest way to deal with these issues. So we do have 0 and 1, but apparently it just wants to do that. Oh, is it because, wait, so if I is not in scene, so for j in range n, well, I've never actually used j. Oh, I need to actually divide I. So I forgot about like the bit shift parts, but I think now it should work now. Yeah. Let's see if the bounds are what they say. Okay, whatever. Maybe it actually is. Yeah, this question is kind of confusing, but well, we got through it. I think like other than the question being like really confusing, like with the bounds and stuff, yeah, it's a very doable question. So thanks for watching, and I'll see you tomorrow. Bye.